Today we're talking about the graphs of quadratic equations. And you might know from a previous algebra class that the graphs of quadratic equations are parabolas. And the key aspects that we need to understand about them are going to be the direction and the shape of the parabolas, the vertex and the axis of symmetry, and the x and y intercepts. I'll also show you how to give an accurate graph of a parabola and also how to give a quick sketch of one, because both of those things will be skills we need going forward. Okay, we know from Algebra 1, Algebra 2, that the graph of a second-degree polynomial is a parabola. And that could maybe look like that, or maybe like that. And maybe even in Algebra 2, you saw that it could go sideways also. That might happen for us later in the year, but it might not. I don't remember if that's a topic that's tested on the CLEP, the sideways parabolas. If it's not, we're just not going to, because you can just imagine switching x and y, making something go sideways. Okay. That's the shape. Now, what causes one to open up versus open down? It's the leading coefficient. Okay. So the a is pretty much entirely determining the shape of the parabola. If a is positive, then the parabola opens up. And if a is negative, then the parabola opens down. Okay, and then, I guess one other thing I have to say about shape is, there's some parabolas that kind of open up like that, while some are very narrow. And that's also determined by a. A leading coefficient that's closer to 0, positive or negative, will give you a wider parabola. Whereas one that is a larger value, farther from 0, will have a narrower parabola. So, let's say a is closer to 0. And for the narrow one, a is farther from 0. All right, I'm just going to tell you how to find the vertex. The vertex, you get the x-coordinate by just calculating negative b over 2a. And the reason why negative b over 2a gives you the coordinate of the vertex is basically due to calculus. So if you've got a friend in calculus, you could have them explain to you why that's the case. But basically, it's going to be at the point where x equals negative b over 2a, the slope will be 0. It'll be flat there. And that's what happens at the vertex, is that it flattens out and then it goes on and does its thing. And we find the y-coordinate by plugging in negative b over 2a in for x. Okay, and then the axis of symmetry, that's something it's a question I haven't seen asked very often, but I know it's one that we asked in Algebra 1 and Algebra 2, so I might as well remind you of it. Okay, so let's just look at the graph of a normal old-fashioned parabola. Here's the vertex, that minimum or maximum point. And we see that the parabola does have symmetry kind of around this line that goes in there. In this case, and in this unit, all of the parabolas we're looking at they either open up or they open down. They're vertically oriented parabolas. So the axis of symmetry is always a vertical line. Now, a vertical line is the set of all points with some similar x value. They all have the same x value. And we already know the x value of the vertex, so the axis of symmetry is the line x equals negative b over 2a. And that's important, because if I ask you for the axis of symmetry, and negative b over 2a equals 3, and you just say the axis of symmetry is 3, you're giving me a number, not a line. Okay, and it's really important that we express the line as an equation. And in this case, it'll be x equals some number, since we're only looking at parabolas that open vertically. All right, so the x-intercepts, well, that's what we spent the past 2 times studying. Okay, where we found the roots of the polynomial, the solutions to the equation, the x-intercepts, the zeros, all those were the same thing. They were the x-intercepts. Okay. Okay, and we know how to find those. That's where y equals 0. Okay, and then, we had the quadratic formula, which gave us the actual specific locations. And then the y-intercepts are easy. They're really easy to find. To find the y-intercepts, well, that's where x equals 0. And if we plug in x equals 0, you'll see that the a will be multiplied by 0, and the b will also be multiplied by 0. So I'll have 0 plus 0 plus c. And so the y-intercept is y equals c. So that constant number on the outside is the y-intercept. Okay, if we're asked to give an accurate graph of a parabola on some sort of given grid, well, we're going to treat this very similar to how we treated the absolute value graphs. Because there's a vertex and there's a symmetry, so we're going to do the exact same thing. Okay, so the first step is going to be find the vertex. And we'll plot the vertex. And remember, that's x equals negative b over 2a. And then y is, well, whatever y coordinate goes with x equals negative b over 2a. Then we're going to plot one other point. And then we're going to use the symmetry of the graph of the parabola to plot another point and then connect the dots. We're not super interested in plotting extremely accurate graphs. That's not something that we really need to do anymore because we've got technology that can do that for us. Okay, so we're going to plot another point and we will use the symmetry. Okay, here we've got y equals 2x squared plus 6x plus 2. And so the first thing I'm going to do is find the vertex. Okay, x equals negative b over 2a is negative 6 over 2a is 2 times 2 is 4. That's negative 1.5. And then y, we are going to plug that in. So 1.5 squared is 2.25. 6 times 1.5 is 90. So that's going to be minus 9 plus 2. All right, so 4.5 minus 9 is negative 4.5 plus 2 is negative 2.5. Okay, so I've got negative 1.5 here. And negative 2.5 down here, so that'll be the vertex. One other point, one that's really obvious to see, is just the y-intercept, because it's right here. This is the y-intercept. The y-intercept is 0, 2. So I'm going to plot that here. And if I had to go to the right 1.5 to get to where I was plotting the y-intercept, I could go left 1.5 and plot another point, also at y equals 2. So I could go over here to where x equals negative 3 and y equals 2, and that would be another point. Then I kind of just plot a little parabola that's going through here. It's a little sharp, but it's okay. You can envision it. That's not so bad. All right, and so that's us graphing a parabola. Okay, and here we've got an equation that's given implicitly. It's not just y equals. So when that happens, I need to solve for y. So I'm going to say that means that y equals negative x squared minus 6x plus 3. All right. And the first order of business is find the vertex. Well, it's definitely negative 3. Okay, the vertex of this thing, x equals negative b, is positive 6 over 2a is negative 2, which is negative 3. And then the y-coordinate that goes with negative 3, y of negative 3, is going to be negative of negative 3 squared, so that's negative 9. Minus 6x is plus 18 minus 3. So this is 18 minus 12 is 6. So the vertex is at negative 3 and 6. Negative 3, here's 6. I'm plotting the vertex. Okay, I know because of this negative x squared, the parabola is going to open downward. But if I just was unsure about that, I'm going to plot the y-intercept. Y equals negative 3. So here we are. It's negative 3. And it seems I went 3 to the right of the vertex to plot 0, negative 3. So I'm going to go 3 to the left of the vertex and also go down negative 3. And then I'm going to connect the dots and make it look like a parabola. Okay, so there we have another good graph. Okay, sometimes we're asked to just give a sketch of a parabola, which is much easier. Okay, we don't need to worry about the relative shape or, how narrow it is, where the specifics of it. We just need a quick sketch. We'll be using that next time to solve some inequalities. And so really when you're sketching a parabola, the first order of business is find the zeros. And then the second order of business is to plot the zeros and draw a parabola that opens the correct direction. Okay, so I guess figure out what direction the parabola opens. And then I'm going to sketch. So for instance, if I had, say y equals, I'll do a nice easy one, x minus 3 times x minus 6. I could draw a quick sketch of that thing by kind of drawing a number line, plotting 3, and plotting 6. And well, if I were to FOIL that, I would get positive x squared, some number of x's, and looks like positive 18. But I don't need to because I know I'm going to get positive x squared, which means that it opens up. Okay, so I know that these are the zeros. And I know that it opens up, so it's going to look like that. Okay, and that's a decent sketch, especially for what we're going to need to use it for. Okay, so here's one that I could sketch. All right, y equals x squared minus 4x minus 5. I'm going to start by factoring that to find the zeros. So that's x minus 5 times x plus 1. Okay, well, I know that that'll have zeros at negative 1 and positive 5. So I draw myself a little x-axis. Here's negative 1. There's 5. I know the zeros of this thing are negative 1 and 5, so I plot those points. It opens up because it's a positive x squared. And I just kind of draw a parabola that connects them. Now, if you feel like, well, this isn't a graph, it doesn't have a y-axis. Well, you could come in after you've drawn the parabola and add yourself a y-axis. Okay, I know the y-axis is going to be between the two zeros. Oh, whoops, looks like I lost part of my parabola. And probably closer there. So there I have an x-axis and a y-axis. And there's the rest of my parabola. Okay, one more to sketch would be y equals negative 2x squared plus 3x plus 1. And this is not factorable. So I'm going to use the quadratic formula to find the zeros. Okay, so that would be x equals negative b plus or minus the square root of b squared minus 4ac is going to be plus 8, all divided by 2a. Okay, so that's x equals, I call that's the same as 3 divided by 4 plus or minus the square root of 17. It's really minus or plus at that point, but it's no big deal. And so I'll say x equals 3 plus the square root of 17 divided by 4, and x equals 3 minus the square root of 17 divided by 4. And then I'm going to, make myself a little sketch. All right, well, 3 plus the square root of 17 divided by 4 will be the bigger one. Then 3 minus, square root of 17 divided by 4 will be the lower one. And this is a downward opening parabola, so I will plot the zeros and draw a downward facing parabola through those points. And there I've got myself a good sketch. If I wanted to know where the axis was, the y-axis, I'd need to do a little analysis on this 3 plus the square root of 17 divided by 4 number. The square root of 17 is just a little bit bigger than 4. So I've got something a little bit bigger than 7/4. But 3 minus the square root of 17 is definitely a negative number. So if I'm going from negative to positive, I know that the y-axis has got to be like right here. Because the y-axis is where x equals 0. I come through, I draw myself a little axis, label them, and I've got myself a good graph. The last thing I've got for you is a situation problem. And almost always these situational problems are going to ask you for like a maximum or a minimum, which is basically a vertex question. But I like this one because it's also asking, how long does it take her to reach the pool? And that's kind of interesting to me, because that's not a typical question. So what I'm going to do, assume the diving board is level with the water. Okay, well, that's not usually how it is, but we can work with that. Okay, so I'm going to say f of x equals negative 16x squared plus 24x, x being the time in seconds, and f being the height in feet. Okay, so the maximum height of her dive is going to be the y-coordinate of the vertex. Right? We know that it's a negative x squared, so it's going to be a downward-facing parabola, and this is the height of her dive. Now, I doubt that, this is the beginning of her dive, but who knows? Okay, so I'll start to find that. Okay, so find the vertex. X equals negative b over 2a. Okay, well, 24 over 32 is 3/4. F of 3/4 is going to be equal to 16, negative 16, times 3/4 squared is 9 over 16, so that's negative 9, plus 24 times 3/4. All right, so that's going to be 6 times 3 is going to be 18 added to negative 9. So that's 9 feet. So the maximum height of Molly's dive is 9 feet. The time it takes Molly to reach this height, okay, well, that would be 3/4 of a second. After she jumped, she reached that maximum height. How long it took her to reach the pool? Well, if the diving board is level with the water, and the starting height, f of 0, is 0, well, then we're just really looking for the zeros of this parabola. Okay, so I know that x equals 0 is one of them, but I feel like this thing might be factorable, so I'm going to try that. So f of x equals x, but there's also at least a 4 in common to that. Yeah, so I'm going to factor out a 4x times negative 4x plus 6. Yeah, and if we're interested in where f equals 0, like say right here, well, I'll say that 4x times negative 4x plus 6 equals 0. And that means that either 4x equals 0, which happens when x equals 0. Now, I already knew that she started out at the water level when she started her dive, so I'm not really that interested in that. Okay, what about this negative 4x plus 6 equals 0? I think that's going to be our time. So I subtract 6. I'll have negative 6. I'll divide by negative 4. It's negative 6 divided by negative 4 is 1.5. So it appears that she is going to hit the water after 1.5 seconds, which actually makes sense because of the symmetry of the parabola. I think that's all I've got